This video is on the objective identify the null and alternative hypothesis involving the hypothesized mean of the differences for the paired data. Now, when you hear the term paired data, it means we're going to be looking at two dependent samples where values in one sample are paired with values in another sample. And there's a very obvious relationship. Usually also, when you have paired data, two dependent samples, the value in one sample and the value that corresponds to it in the other sample are usually pieces of data related to the same object or the same person, as we'll talk about here. Alright, so again, if you are unfamiliar with the topic, want to see more about it, click on More Instruction and look at their videos, their notes, their examples, and hopefully those help. Okay, so here, a physician wants to determine if a supplement is effective in helping men lose weight. She takes a random sample of overweight men and records their weight before the trial. She then prescribes the supplement and instructs them to take it take it for 4 weeks while making no other lifestyle changes. After the 4-week period, she records the weight of the men again. Identify the null and alternative hypothesis for a hypothesis test where D is the weight after trial minus the weight before the trial. All right, so here's what's happening here. Now the population is these overweight men. Right? She took a sample of overweight men, and in what she's doing with this group of men is actually taking two samples of data, and these samples are going to be related. They're going to be dependent. Sample 1 is, say, the weights before taking the drug for 4 weeks, before taking this supplement. And then sample 2 are the weights of these men after the 4-week trial with this supplement. So these are actually paired, right? Because each pair of data is going to be related to one person or one of these men. Man number 1, say, his weight before was 252 pounds and his weight after was 234 pounds or something. And then man number 2, again, that's why this is called paired data, because each pair of data relates to one person or one object. And then man number 2, in sample 1, the weights before, say, weighed 221 pounds, and then after weighed 219 pounds or something. Okay, and then this would happen to man N, 1 through N here, and say this nth person weighed 178 pounds before and 184 pounds after. Right? So what we have here, again, these aren't the exact, they didn't give us any numbers or anything, but this is what we're going to be seeing throughout sections this section on testing for the the mean difference in paired data. This is paired data again, because each pair of data corresponds to the same individual. Right? So that means I couldn't change these numbers around. Right? I couldn't move the 184 and replace it with the I couldn't switch the 234 and the 184 because this 184 is related to the same person as the 178. Right? If I change values, I'd have to switch men. Right? I'd have to switch all the pairs. You know? So this is paired data. Can't mix stuff around. Each pair relates to the same individual. And being that that's the case, then you would say that these two samples, right, the sample of data, of the weights before the trial, and the sample of data, these weights after the trial, these are definitely linked. These definitely have a relationship, right? It's because they're related to the same person. So these are definitely dependent samples. Okay, and if that's the case, we have two dependent samples of paired data. What we're going to end up doing is, you're going to be performing a hypothesis about the average difference between these pairs of data. So I'm going to create like a third column where we look at the differences. To see if there's any significant difference between these pairs, right, between these values in the pairs. Then, again, they called it D, and this will usually be called D in our all these problems. And the D they're asking us to calculate here, or the D they're talking about here, is the weight after minus the weight before for these men. So, say D1 for the first man, what's the difference in his weight after this trial? So say I would take 234 minus 252, that'd be negative 18, meaning a loss of 18 pounds. And then say D2 would be the difference in weights, weight after minus weight before for man number 2. 219 minus 221, negative 2, meaning a loss of 2 pounds. And so on. And we do this for all, n pairs of data, say D sub n here. Take weight after minus weight before. Now 184 minus 178, that would be 6. So this means a gain of 6 pounds after the trial. Right. And then what we're going to calculate here is D bar eventually. Right. And eventually we're going to find D bar, and you remember X bar, right? You remember that's just the mean of this sample. This is the mean of these sample differences. All right, and not only are we going to find the mean of all these sample differences, but also you're going to be, having to find the standard deviation of these sample differences, which will be called S sub D, right? The standard deviation of the sample differences. So this is the sample standard deviation of the differences between those paired values of data. All right, you're going to be finding those things. Now, every hypothesis will be about, well, what if I did this for every overweight man, right, instead of just this sample? So you're going to see mu sub D, right? All the hypotheses will be about this value. This is the population mean difference. So if I were to do this, record the weights before taking this supplement for 4 weeks and then record the weights after, if I were to do this for every overweight man, every possible one, the entire population, and then look at their differences and look at all possible different, what would be the average of all those differences? That's this mu sub d. Okay. All right, and then as with every hypothesis test, right, there is a claim or some belief, some claim, some statement that's being tested. Now, this physician, it says in the first sentence, wants to determine if this supplement is effective in helping men lose weight. So what she's saying is she's hoping that the average for the entire population, she's hoping that the average difference for the entire population is negative, right? Because again, a negative difference means that there was weight lost if you did weight after minus weight before. So she's hoping that the average difference in weights, weight before, to weight after minus weight before, she's hoping that that average difference is negative, meaning that, so this claim here is that, the supplement helps them lose weight. All men on average, lose weight with this supplement. Let's say lose weight. That's what this is saying. And then, once a claim is established, you can set up your hypotheses, right? The null hypothesis, the alternative hypothesis. Now, this claim does not involve equality, right? So this is going to be represented by the alternative hypothesis, right? That the average difference for all men between their weight after and their weight before is negative, right? Or that, men on average will lose weight with this supplement. And then remember, the null hypothesis is going to be the opposite of this, right? That mu d, this mean difference for all men, will be greater than or equal to 0. But you don't very often see this. I mean, this is a totally valid null hypothesis. It's just very often all you're going to write is the equal part, what we're going to be assuming when we run the test. So we're going to assume the equal part, that the mean difference for all men is equal to 0. Now, if you assume this, that would be assuming that all men on average don't lose any weight. They also don't gain any weight. They just stay the same weight they are, and the supplement is not effective. Right? So you assume this. You assume that the supplement is not effective. Take your samples and stuff and do all these differences. Find D bar, find SD, and then run the test. We'll get to all the steps of the test later, in other videos. And then you're going to say, hey, based on that sample, do I reject this statement or not? Right? Do I reject the null hypothesis or not? And then you make your final conclusion, right? Some statement about the claim. Do you support the claim? Do you not support the claim? Based on the sample evidence. All right. So looking back at the thing there, the null hypothesis and alternative hypothesis would be this one, right? Based on what I just wrote. Great. And again, they read through your answer explanations, right? Again, hopefully watching me do this, explain this, looking at the more instruction, reading your answer explanations when they come up, hopefully all this stuff helps you when you work on this on your own. And thank you very much for watching.